Video, I'll give a short introduction to cyclic codes. So let's get straight into it. Assume we have a NKD code. And so this is a linear code. And we code C, and it's called cyclic. If for all code words in C, C0 to Cn-1, C the word Cn-1, C0 to Cn-2 is also in the code. So that it's kind of clear why it's called cyclic. And now let's look at some easy first properties. So let's say we have this code word C0 to Cn-1, and we map this to the vector C0 plus C1x plus Cn-1 x to the n-1, and we consider this as element in fq of x modulo x to the n-1. Okay, this x to the n-1. Well, this is, at first, it's a bijection, which is quite clear. Well, it's a bijection between this and a subspace of this vector space of fq. And now let's make it first some notes. First, fq of x modulo x to the n-1 is a n-dimensional fq vector space. So we have the same dimension, and well, now why do we consider this polynomial x to the n-1? Because we could have chosen any polynomial of degree n, and if we mod it out, we would have gotten an n-dimensional vector space. So let's look at that. So let's multiply x with a code word, or rather the image of a code word. So this is C0x plus and so on. And now we see Cn-2 x to the n-1 plus Cn-1 x to the n and x to the n is equal to 0 in this, equal to 1 in our vector space. So what we get is that this is Cn-1 plus C0x plus Cn-2 x to the n-1. So we see if we multiply with x, we get another code word if we have a cyclic code. And so what we see in general that let's call maybe this map phi. So what we see is the image of phi in this algebra is an ideal. And we can also go the other direction back. So if we have an ideal in FQ x modulo x to the n minus 1, then we get a cyclic code we get a cyclic code which is a subspace of FQ to the n. So these are some basic properties of cyclic codes. Next time we will see a little bit more about cyclic codes, but this is enough for now. So the main thing to take away is that cyclic codes are basically ideals in this algebra over FQ.